in the last class I had given these three questions to solve, and these three questions would fall into the categories case 1, case 2 and case 3, which we discussed depending upon the type of the roots of the auxiliary equation. So let us solve these questions one by one. We begin by solving the first question. The first step is rewrite your differential equation in terms of operator D. So we rewrite our first question. The operator D gives us D2 plus 36 D times Y equal to 0. The second step is identify the auxiliary equation. So auxiliary equation is D square plus 36 D equal to 0. And the third step is identify the roots of this auxiliary equation. So the roots were denoted by m1. Here the root will be 0 and m2, which is equal to minus 36. And step number 4 will be identify the case to which it falls. The case to which it falls is case number 1, when the roots were unequal and real. So you will choose case 1 and substitute the values of m1 and m2 in equation number 3. So substitute in equation 3 and the solution will turn out to be y is equal to c1 exponential of 0 t will give us 1 plus c2 e to the power minus 36 t is the solution. So from first question we have seen that when we have a second order homogeneous differential equation, it can be solved in 4 steps. Let us now mark the steps. So this is your step number 1, which is step number A, that is rewrite your differential equation given in terms of operator D. Step A. Step B is find auxiliary equation. So we can say step A is write in terms of operator D. Step B is find auxiliary equation. Step C is find roots of auxiliary equation. And step 4 is identify the case. Now let us use this 4-step procedure to solve question number 2 and question number 3. So let us come to solution number 2. Apply step number A. This is step number A. Apply step number B. Then apply step number C. And then the last step, step number D, when you have to identify the case. So this question falls into case number 2, the second case which had real and equal roots. So you will use equation number 4 of the last class. So substitute in equation number 4 and that will give us the solution y is equal to c1 plus c2x e to the power 3x. This is your last step which gives us the solution, complete solution. Then let us solve question number 3. We will use the same method. Step number A. Step number B. Write the auxiliary equation. And the auxiliary equation gives us roots, which will be our step number C. So this step number C will give us the roots which are m1 and m2. Identify the case. The case is again case number 1, which was real and unequal roots. So you will put m1 and m2 back in equation number 3 and get the solution. Which is our last step, step number D. Sorry, this should be 1. First root will be 1, second root will be 2. So this is 1. But still till this stage in these 3 questions we have not encountered the last case where the roots of the auxiliary equation are complex. So let us take one more question, and the question is to solve differential equation double derivative of a variable q, say with respect to t, minus 5 dq by dt plus 7q equal to 0, and this will give us complex roots. So let us again apply the same method. Step number A. Step B. Write auxiliary equation. Step C. Find your roots of the auxiliary equation, and they will be and step number D is identify the case. So when you identify the case, it turns out to be case 3 of the last lecture, where the roots were complex and the solution was represented by equation number 5. So now substitute in equation number 5 of the last class, which gives us complete solution, and the complete solution is so you can either take iota along with A2 or can write it separately.